in day-to-day life, you communicate with many people, and a lot of sensitive information gets exchanged. And it might happen that this sensitive information it gets leaked, or it might get revealed, and somebody else or any man in the middle can attack your information. So we don't want that to happen. And for remedying that problem, we have proposed a system where we remove all the sensitive information, and when the initial communication it reaches the end user, all those sensitive information gets removed. So how is that done? I'll just brief from the beginning. So our problem statement is about performing semantic analysis on the voice, where all the sensitive information is removed, and then transferring that information to the end user. So this is a higher level diagram where initially whatever is spoken over the phone is transferred to the cloudlet, and the cloudlet is known to provide very high efficiency and high processing power. So we are using this inherent feature of cloudlet to perform our heavy semantic analysis. And after that, the process data is again transferred back to the cloud or any end user. So what all technology stack we are using here? So we are using Gabriel. So Gabriel is a mediator between client and the cloudlet. So if I speak something and I want to transfer that information to the cloudlet, I'll use Gabriel as a platform, or rather as a mediator. And after that, the second one is CMU Sphinx. So it is easier to perform semantic analysis on a text file rather than directly on a voice. So what we are doing is we are converting a voice into a text file using the CMU Sphinx. Then we are performing some semantic analysis on that, and that's the way we are achieving our target. So how we are doing our semantic analysis. So there are few pattern matching algorithms and regex algorithm we are using to do semantic analysis. This is our cloudlet architecture. So this device com it acts as a port. So where the end user interact with the cloudlet. So if end user wants to transfer any information over cloudlet, so device com act as a port which uses Gabriel to get the data, and that data is transferred over cloudlet. And this is the PubSub. What it does is it is similar to REST, which is normally used in web, where the all those information, all the voice, it gets published over the cloudlet and is ready to be subscribed by the subscribers. And we are using this user guidance VM, where that's a VM on cloudlet or an instance of a cloudlet where we perform all the semantic analysis. So this is a in-depth overview of how our system works. Initially from the Android client, you just speak something, and that gets transferred to the cloudlet using Gabriel. And after that, we are converting that to a raw file. And why we are doing that is because we are using Sphinx for converting the voice to the text file, and raw file is quite compatible with Sphinx for the conversion. And after that, we are performing semantic analysis on the text file. We are using some regular expression and pattern matching algorithms to achieve this. And once we perform the semantic analysis and we have a list of keywords which are sensitive information, we need to find out the exact location of the sensitive information in the whole voice channel or voice communication, because we don't want any actual information to be blurred out, because it doesn't look good. So suppose if I say anything like my password is Apple, and my system tells me that Apple is a sensitive information which you need to blur. So what I'll do, I'll find out in the whole voice where this sensitive information starts and where it ends, so that I'll blur that particular part to achieve accuracy. So once that is done, and I found out the timestamp where it actually starts and it actually ends, so I'll just put on some filler or put on some noise like beep. So my output will be like my password is beep. So that is the processed audio. So what we are going to do now is we are going to speak something on the Android client, and this algorithm works now. We are going to speak something on the Android client, and we'll get the output where the sensitive information will be blurred out. She's Ayushi. She's going to speak now.
This is the final demo and my password is mango.
So she just said my password is mango, and my system will understand that the password is mango, and it will try to blur out that part from the whole communication. So now we are running a semantic analysis over Cloudlet.
And my password is. I'll just play it again. This is the final demo and my password is.
So as you just hear that mango was the sensitive information reported by our system, and it got blurred out in the whole voice. So this is how we are removing, or we are removing the sensitive information from the whole communication. Yeah, that's it.